Let's talk about composting and mulching, two things that are really important, very simple things to do, but very important for keeping the soil health and fertility and ecology in good condition to support your plants. Typically, we take grass clippings, prunings, and other organic green waste from our garden, from kitchen scraps too, and put it in our green bins. And here around Santa Barbara and maybe other parts of the country too, and it's taken away and chopped up and partially composted, and then can be obtained by people for as mulch through the city. So we we send off a lot of our organic material that's been produced by our plants on site, and that organic material is really the fruits of some of our labor. So we've paid money for water. We might have bought compost to bring in. We've grown our plants, our labor, and these plants grow. And then when they get too big, we cut them and then send off the organic waste somewhere else. So better to keep it on site. That's your money, your time, your soil fertility right there in that green waste. So if you can compost and mulch your own stuff on site, then you're really keeping all that ecological capital right there for you, and not being more efficient with your money and time. And it's better for the environment. So not that many people really want like dead, branches lying around their yard, and it's kind of our culture to clean everything up. And so what we can do with that is compost it, of course. If you leave landscape soils on their own, they slowly become depleted in organic matter and nutrients. All the plants are using up the nutrients and the bacteria, the organic matter in the soil. So if you don't ever add new organic matter, which has the nutrients in it, then your soil will slowly become poorer and poorer quality, more and more nutrient poor. So composting and adding that and keeping it there on site will keep your soil in good condition. The whole process of composting and mulching is not something humans came up with. Composting is the speeding up of the decomposition process by humans, but it happens naturally too. The word compost comes from decomposition, and that occurs everywhere. And it's happening all the time as vegetation breaks down. The bacteria and microbes in the soil are decomposing that living tissue and making it into smaller bits of non-living organic matter. And organic matter is just tissues and chunks of material that have come from a living creature, an animal, plant, microbe, anything like that. And that a lot of it ends up in the soil. It's the biological action of the soil microbes that create this product called humus, which is very rich and dark, almost slimy, and it makes the soil very fertile. It's full of many different organic compounds. So when you see really dark, rich compost, that has a lot of humus in it. Soil microbes also secrete this polysaccharide layer, gooey layer that's on the outside of their body that helps them slip and slide around to get to whatever they're trying to ingest. And that helps make the humus too, and helps the soil structure. Where are all the most of the soil organisms? They're in the top few inches of soil. I wrote here 1 to 3 inches, but it varies. But the top part of the soil, so the top soil itself, which is the top layer, is the place in the soil ecosystem where there's the most moisture, the most air, the most nutrients, and thus the most microbes. Also, the most plant roots are in that top few inches too. Think of a big old coast live oak tree. You think of their roots going deep down into the ground, 10, 20 or more feet. And that's true, but those are the roots that are called the support or structural roots that hold the plant upright, more so. And most of the smaller, finer roots, or what are called feeder roots, are in those top few inches of soil, even in a big tree. So that's why it's really important not to have compaction under big oak trees and other trees, is even though you're not damaging those deeper roots, you are damaging all the fine roots, which are very tiny and the ones responsible for interacting with the microbes and getting soaking up nutrients and water and feeding microbes to get more decomposition occurring. So that's what's happening in the top layer of the soil. The process of making nutrients available from the organic matter and humus into a form is so small, it's like an elemental nutrient. You know, if you've got nitrogen in or something like nitrogen or sulfur or phosphorus or potassium that's bound up in the body of a bacterium or even a root, that is not available for the plant to absorb a big chunk. It has to be broken down through decomposition into almost elemental form, and then the elemental, meaning like just nitrogen alone in a very small molecule, can get dissolved into the water in the soil, and then the plant can soak up the water with the nutrient in it. So that process of making these nutrients broken down into their small mineral form is called mineralization, and it's done by microbes in the soil. And as I mentioned in the last slide, it's not just that the microbes like to hang out where there's roots and moisture and air, but they're also hanging out near the roots of plants because those roots are producing sugars and surrounding their root tips with sugars to attract the bacteria to them, and it feeds the bacterium, and those bacteria then are more concentrated around the root tips and will do more decomposition of organic matter also at the root tips and provide more nutrients for the plants. So it's really a reciprocal relationship between the plant root tips and the plants and the microbes. Making a compost pile: 5 basic ingredients: air, water, carbon in the form of dry organic matter or brown material, nitrogen in the form of fresh organic matter or green material, and some kind of inoculant, compost or just soil, native soil right there from your garden. You can also buy starter kits of powders that have microbes in them, and sometimes fertilizers that will try to kickstart the compost pile. I'm old school. I don't think those are really necessary. They can help, but they don't help that much, not as much as you think. It really matters a lot more if you get your brown and green material ratios correct, and those things will have plenty of microbes on them already to get this going. But you can do that. You know, the products are nice, and you can do that just to hedge your bet if you'd like. You want to have a good carbon-nitrogen ratio. When you're mixing the brown and the green material, you want about 2 to 3 times as much brown material as green material. And as I said, the brown material has the carbon in it mostly, and the green has the nitrogen in it. It has other things too, but that's what carries most of the nitrogen that you're going to put in your pile. When you use that ratio, you get to a compost pile carbon-nitrogen ratio of about 30 to 1, and that's a good ratio. So we use the twice as much or more, 2 to 3 times as much brown as green. We use that ratio of bulk materials as a way to approximate that will give us about 30 to 1 carbon to nitrogen, because obviously leaves and green leaves and green material and brown material aren't fully carbon and nitrogen. There's other things in there, so this is what gets you there. And here's just a list of other ratios of carbon to nitrogen of other materials. When you're using something like sawdust, wood, paper, it's really high carbon, and it's obviously not a green material. And so those are the things that have very high carbon. On the other end of the spectrum, like alfalfa, sewage sludge, food waste from the kitchen, that's higher, has higher levels of nitrogen in them by proportion. You always have more carbon than nitrogen. That's just the nature of organic matter, but some have more proportionally more nitrogen than others. So a very common and recommended home compost pile or residential is a thermophilic compost pile. You've got your brown, your green, and you've got some water, air, and microorganisms and macroorganisms are added by adding the native soil as your inoculant. And then, of course, time. It takes time. That's what the squiggly line is. And some effort on your part too to create finished compost. In our climate here in southwestern United States, it takes a few months to get finished compost. So you start a pile with the right proportion of ingredients. You keep it moist. You turn it periodically. You watch its temperature. And you do that for a few months. You turn it less and less over time, but it's not something that happens in 2 weeks. It's a longer process. So you might need a few piles going so you can keep adding to, when you get new waste every week or so, you wouldn't add it to the pile that's already started, but you could make a new pile. This is just one of many diagrams of a compost pile. Here it's really showing you the exact same type of ingredients. You've got dry material, you've got moist activator material, which is like the inoculant. You've got green material also. It's all in there. Look at, there's alfalfa meal as the green material, and dried weeds as brown material. Lawn clippings is a green material. Rice hulls as a brown. Blood meal would be more of a green because it's so high in nitrogen, etc. And we do them sometimes in layers like this just to keep track of the ratio of brown to green. When you're done though, you really want to mix it all. If you started your pile like this with layers, that'd be great. Now turn it and mix it as much as possible. The minimum size for a thermophilic compost pile should be 3 cubic feet. If it's smaller than that, you have too high of a surface to volume ratio, meaning there's not a lot of inside compared to all the surface area on the outside, and the inside won't get warm enough. It needs to be at least 3 cubic feet to have kind of like an insulative layer so the interior can really heat up and not get cooled down by the air temperature on the outside. And this is another breakdown of layering of ingredients if you wanted to try that. Once you get into composting, you'll see there, and reading about it especially, there are many methods for composting. This is a thermophilic aerobic. Both of these shown here and the one I talked about in the previous slides are thermophilic aerobic piles. So we're building a pile the right size with the right ingredients to encourage and allow thermophilic, heat-loving aerobic bacteria to proliferate and do the decomposition at first, at least. Later, after about a month or so, the fungi will take over. But that's what these are. These are some other, this is the indoor pile method. That's someone's name, not as opposed to outdoor. And the biodynamic pile method. There's many different kinds, and they each have their own benefits and pros and cons depending on the situation. Some of these work better in moist tropical climates. Some work better in dry climates. Some depends on just what materials are available. So lots of different ways. And when you make a compost pile, I'm giving you the basics right now, and you will find ways to tweak it as you go. It's never going to be perfect. You're going to find that your first pile doesn't get hot enough, and you're going to have to remake it by adding more green, or it doesn't get, or it gets too hot, and you have to stop and turn it and maybe add more brown material, or you're finding your materials ratios weren't quite right for your situation. It really is kind of like baking. It doesn't, if you're doing baking from scratch, you're always kind of learning each time and adapting and learning and making it more suitable to your site. So again, these are just starter recipes for composting. It is really helpful to have a compost thermometer. Your pile really needs to get over 131 degrees in the first few days for the process to work, to really decompose all that organic matter. It needs to be 131 for 3 days at least to kill the weeds and the pathogens. If it doesn't get to that temperature, this is Fahrenheit by the way, the weeds and the pathogens aren't killed, and then you've got some problems. You're adding compost to your garden that's going to have weed seeds and other pathogens from the original materials. If it gets too high, the pile can go anaerobic, meaning all the oxygen gets used up too fast by all this really fastly growing bacteria, and some of them will die. It'll kill some of the fungi too. So right around 140 degrees Fahrenheit is ideal. Less nitrogen gas is released, and that's good because we want to keep it in the pile, the nitrogen there. We don't want it to volatilize because it's such a hot pile, and because that nitrogen is good for the plants. If it's too cold, you can always add more nitrogen in the form of manure or alfalfa or green material. It's harder to decrease the temperature of the pile, but turning it can help. So in general, a compost pile, when you start it around here in southwestern United States, within the first day or two, it should go up above 131, up to about 140, and it should stay there for a few days, like 3 to 5 days at the most, and then it will naturally start tapering off. You do not expect it to stay up at that temperature for very long. Like I said, 3 days to kill pathogens and diseases and weed seeds. So it would be normal for you to see it get really hot for a few days, about a week, and at 4 or 5 days it starts to cool off, and that's okay. And you can turn it a couple times in there if it gets too hot, and keep it moist, but not too wet. And then you start turning it about once a week after that, just to mix it up, and for about 6 weeks, and then you can stop turning it and just leave it there. And at that point, all the green material is gone, and so all the bacteria that really loved eating all that green material start to diminish, and you start to have the fungi take over and start to chomp on the brown material. And that's the slower kind of tail end of the compost pile's life. After the first month, you've got 2 to 3 or more months after that where the fungi start to proliferate and break down more slowly all that brown material until it's all gone. Sticks, wood chips, sawdust, whatever you're using. It's thoroughly decomposed when it's no longer warm or hot, no steaminess, no pieces of big material visible, or if there are, they're not that many. It smells good, doesn't smell kind of stinky like it might at the beginning. Again, turning the pile a few times to incorporate oxygen while it's composting in that after the first week. And the soil is going to be aged properly, so when it's all done, the organisms or the microbial communities, meaning all the different types of microbes in there, are about the same as what you would find in your soil. When you first start your compost pile, maybe a week or two or even a month in, the microbes in that compost are not very similar. The populations, so the communities, meaning that all the different types of microbes, are not very similar to your soil yet. It takes a couple of months or more for the microbes to kind of settle down and get back to being the type of microbial community as you would find in soil. That's when it's done. That's when you can add it to your garden. Here's a few different types of composting bins. You've got the tumblers, that spherical one, these other ones that look more like a box or a cage. There's many different types, and it does depend on what you like to use. I don't really like the tumbling ones. I've tried them before, but they're completely contained, and they tend to go anaerobic on me. Maybe I just don't go out there enough and add enough dry material at the beginning, and I'm not really sure why. I don't recommend them for that reason, but if you have one, you're welcome to try it. I like the open cage bins and having a few bins kind of right next to each other, so you can turn, when it's time to turn it, you can turn it from one bin directly into the one next to it and back and forth, or down a line of a few bins. Those are the type that I like. The fastest method that I know of, the Sri Lankan method by Victor Dalpadado, is a 2-week composting method where the materials are similar ratios, but you chop it up as much as possible, and it's like a tossed salad, and all of those different organic particles that are in that compost pile are small and mixed, and the microbes have quicker access to them and they decompose the material quicker. This Sri Lankan method is a method that was developed and used in Sri Lanka, so a more tropical climate, And that's part of the reason it only takes 2 weeks. It's a very high decomposition type of climate, but it's also because the particles are so well mixed and so chopped up so finely when you start your compost pile that they decompose quickly. Here's a nice image of a previous class making a compost pile out in the garden. So what's the difference between mixing compost into the soil and leaving it on the surface? Not really a lot, except that mixing the compost into the soil itself can help spread out that really good organic matter and nutrients more quickly if your soil is poor. Leaving it on the surface is something you can do after your soil, gets to be a pretty, good quality. You can just start adding the amendment on top, and over time it will infiltrate and the organisms will work it into the soil. Here are a few other methods of composting with compost piles. Using and spreading mulch is a form of composting, as long as you keep the mulch moist. Windrow composting is a more of a large-scale type of system where you have a long compost pile and add new material to one end, and as that ages in compost you turn it kind of down the line of that long pile, and so one end new stuff is added, the other end is pretty much finished, is where the old stuff is. Digging holes just to put plant material and pet feces in are a type of composting. There's open area piles like we did with thermophilic. You can use tumblers, worm composting, etc. Or skip the whole composting step altogether and plant directly into the manure source, like this tree that's growing out of a donkey that I saw in Kenya. Just a joke. This is a great reference book, the Rodale Book of Composting. It really summarizes many of the different methods that are out there. So now let's switch to a discussion of mulching, which in my mind are really just very thin, spread out composting piles. A little less focused on getting the material to compost quickly, but in a sense adding mulch and organic matter, as long as you have moisture, is a form, a slower, more indirect form of composting itself that happens naturally out in a forest or chaparral around here, where you have leaf litter coming down everywhere and it slowly decomposes. That's similar to a type of mulching and composting. So mulching is natural, and you can do it yourself by buying mulch or obtaining mulch and spreading it around your garden or yard, or you can just let things go natural and whatever leaf litter drops down can become a mulch. The benefits of mulch are that layer of organic matter reduces weeds. Not all weeds, not the rhizomatous weeds, but it reduces the broadleaf weeds by just having a layer of material on top of them. It can add organic matter to your soil, which is helpful for the soil's health itself, and protects the soil structure to have mulch on top of it because it retains the moisture in the soil better and reduces some compaction so the pore spaces stay open, more water can infiltrate and air can vent. That's how the structure maintains a benefit in the soil, and it maintains soil moisture to have mulch on top, and it moderates the soil temperature, meaning if the layer of mulch, it's kind of like a blanket, it will keep the daytime soil cooler by having that layer of mulch on it, and the nighttime soil warmer, so the roots are not exposed to such extreme, and the microbes too, and they survive better and do better overall. So what's the difference between mulch and compost? Can compost be a mulch? Can mulch be a compost? Deep philosophical questions of the home composter. Well, mulch is usually a top dressing. It's something you put on top of your soil. It's not something you mix in, usually. So mulch could be like wood chips or straw or lava rock or California gold gravel. It can be shredded mulch. It can be like gorilla hair, that redwood bark mulch. Lots of different types of mulch, and those are always added to the surface of the soil, partially to perform the functions we talked about of moderating the soil temperature and maintaining soil moisture, etc. So usually mulch is not something you mix in. You don't want to take wood chips and mix them into your soil, or gorilla fur, hair, or all of those kind of bigger chunked type of mulches. However, if you're using compost, really only in this case, if you're using compost as a mulch, that could be mixed in. But when you do mix it in, then it's really no longer a mulch, because mulch is what you put on top. So compost can be a mulch, but mulch is usually not used as a compost. So mulch you leave on the surface, compost you usually mix in. So I just listed the positives of mulch, but there are negatives too. Not everything is perfect and does all. So if you have too much mulch and there's a lot of moisture in there hanging out in the mulch, it can encourage some soil pathogens and plant pests to be happier and proliferate inside that wet mulch that you've put on the soil. It can create a soggy situation too for the soil, which isn't good. That'll encourage anaerobic microbes and organisms to do well. Also, a layer of mulch will make Bermuda grass, crabgrass, kikuya grass happy. Those rhizomatous grasses will spread with mulch. So it's negative for those weeds, and positive like in the sense that mulch will suppress other weeds, but not those weeds that tend to spread. So there are lots of different types of mulch that you can use out there. Almost anything can be used as a mulch, especially if it's organic matter, tree trimmings, grass clippings, leaves, cotton, clothing, or sometimes even carpet we used to throw in there when I lived in Guatemala, and we did a lot of composting there. Green mulch, wood chips, etc. And some mulching rules of thumb. So real basic stuff to go by. If you want to retain moisture, do about 2 inches. You can do more, but if you're just trying to retain keep the moisture in the soil, 2 inches is enough if it's a pretty thick mulch. If you want to suppress weeds, like broadleaf weeds, not those rhizomatous grasses, do about 4 to 6 inches of of mulch on top of your soil. That way you've got at least 2 inches to retain moisture and 4 to 6 inches to suppress those broadleaf weeds that can't grow up through the 4 to 6 inches of mulch. So you're doing both of those things. Only about 3 inches are needed to regulate the soil temperature and root temperature, which is helpful to moderate the soil temperature, and roots aren't exposed to the high swings in temperature and don't get damaged by that. And only 1 inch is needed to protect the soil from harsh sunlight. So if you want to do it all, do 4 or more inches. Another tidbit is to not put the mulch up against the trunk or stem of any plant, like a shrub or a tree or anything. The mulch will retain moisture in general, unless you're using lava rock and gravel. But even gravel can do it too. And that moisture sitting on the stem of a plant will cause it to rot. So keep it about 6 inches away from any plant. Like I always say, like a dinner plate size open spot where there's no mulch next to the stem of the plant in the center. Of course, there are also living mulches you can use. So not just these things that are organic matter from a living organism, but you can do cover crops, legumes, perennials that grow and add a lot of organic matter and right on the soil as they grow. You can do it that way as a cover crop or ground cover, and it benefits by adding organic matter to the soil and protecting the soil from drying out and from getting too hot or cold while the plant is living. Cover crops are usually grown for a season and then chopped down and just left there as a green mulch. But you can also have plants that are perennials, not that you chop down, but they just stay there. And that would not be a situation where you're going to now plant some kind of crop because you've got perennials there. But it could be a way just to think about mulching. Mulching doesn't have to be something you kind of buy and add to the soil. It could just be your ground covers are doing some of the same functions and keeping the soil healthy for all the plants around them and themselves while they're growing. Sheet mulching is a way to Well, mostly it's used to suppress some type of plant growth that you don't want, weeds or lawn or something that's there and you want to change it into a different plant palette. So often I hear about sheet mulching over turf or lawn, and you put down, you dig out the lawn as much as you can, but there's always some like rhizomes and roots left, so the lawn tends to grow back. Well, you can put down wet cardboard over that, then compost on that, and then mulch on top of that, and plant whatever your new plants that you want in there through little holes in the cardboard. And the cardboard, if it's done right, there's some details to it to make it be done correctly, but that will suppress all the previous lawn or weeds or whatever you had under there that you're trying to kill. That'll suppress that and slowly kill those off, and you'll just end up with the new plantings there. So it's a quick way to transform a certain type of landscape planting to another type.